Hello everyone, this is Mr. Kalonji here. Today we are going to talk about probability. What is probability? So probability basically by definition here, it's the chance or the likelihood that a particular event will occur. Because most of the time in statistics we make decisions based on uncertainty. We are not really sure. So with probability, what it allows us to do is to quantify and measure those uncertainty by looking at the chances of whether it will occur or not. So we have two main type of probability. The first one is what we call subjective probability, and the second one is objective probability. Subjective is more of an intuitive type of probability where you just feel it in your gut, or you are an expert in a certain topic or in a certain research area. Those are just your prediction based on what you feel, you know. But this type of statistic, basically it's not measurable and it's not reliable. So we tend to go for the objective type of probability because that can be statistically tested or verified. And the way we verify those, it's through surveys and observations of event. This is what we're going to do on this chapter. And there's another type which is you can also check, verify the probabilities through mathematical models, using mathematics to check the probability. And one of the basic formula for probability is what you see here, P A bracket R over N, where A is the event or that specific property that you're checking, R is the number of outcome of that event A, and N is the total number of all the possible outcomes, and PA is the probability of that event A occurring. So, like I said, now under objective probability, we have the first one which we called a priori type of probability, which is known outcome, like tossing a coin, selecting playing cards, and rolling dice. You already know all the outcomes, head or tails. And you have empirical probability. So that's where the values R and N are not known, but we can observe them when we collect our data. This is what we're going to see today. And there's also the mathematical one, like I said, that is with distribution of functions that we're going to see using chapter 5. So what are the properties of probability? First of all, a probability values only lies between 0 and 1. So any value will not exceed 1. Alright, and that's why you see that we put them into numbers and decimals, but the highest probability you could get and the most highest level of certainty, I would say, will be 1. And if an event cannot occur, it's actually impossible, then the probability is 0. If an event is certain to occur, you know that it will happen, you're very sure, the highest probability you get is 1. And the sum of all the possible events, by that I mean all the collectively exhaustive sets of events, will always be equal to 1, like I said. And complementary probability is this. I will explain it better on the blackboard. So if you have the probability of an event A occurring, then the probability of that event A not occurring is just 1, this one here, which is the sum of all the probability minus that event occurring. For example, if there's 7% chance that a part is defective, then the probability of P parts being defective is equal to 0.07. So you must understand that this 0.07 came by dividing the percentage, the 7, by 100. Like we said, it's a chance. If we don't express it in this digit, you can also get it into percentage. So which means that the probability of now not having a defective part will be 1, which is the total likeliness of having that event occurring, the highest number 1, minus that probability, then we have 0.93, which is the probability of not having a defective part. Alright, so now let's go into depth and look at the property of probability. I'm gonna switch to the blackboard now so that we can work out these examples. Alright, so welcome back to our blackboard here. We have this table 4.1, which you would find on the slides and on the textbooks as well. So this table is showing us the petrol brand preference and frequency content percentages of these brands here: BP, Caltex, Engine, and Shell. This is the count, these are the counts, and we have the percentage on the side. And we've been asked a few questions here. The first one is, what is the likelihood that a randomly selected motorist will prefer Engine? So for this question, let's do it here. So let's say here, let's consider A here as the motorist that prefers what engine? That prefer engine. Okay, so this is the probability of A. Then from our formula, we know that we said what, that P of A is equal to R divided by N, right? And if you remember, what did we say? That R is the number of outcome of that event A, and N is the total number. So looking at our table here, which I'm just going to choose in green, where is the engine section? This is the engine section. Okay, so the engine section is here. We see that the number of time that someone will come and choose engine. So here the number of outcome of engine, yeah, we have a 6, and the total number here, everything is 50. So we see that our R is 6 and our N is 50. And going back now to our calculation on the side here, then we would say that the P of A now, the probability of this event that a motorist will prefer engine, is equal to 6 divided by 50. And taking your calculator, you see that you get something like 0.12. And because it's probability, you always would want to answer that in percentage. Then times 100, you would say, therefore, we have 12% chance that, or 12% chance of finding a motorist who prefers, I'll just write E, engine. Alright, so for our question B here, they're asking us what is the chance that a randomly selected motorist does not prefer Shell. Okay, this is a very interesting one, because remember when we spoke about the complementary probability, if the probability of an event is P of A, this is the probability of that event occurring, then the probability of PA not occurring is 1 minus that probability of A, because remember we say that the all probability goes only within this range between 0 and the highest one you can reach is 1. So if you're 100% sure, this will be 1, and if it's actually impossible, you will get 0. So keeping this in mind, this is how you are going to work B, because you want to find out what is the probability of finding a motor that the randomly selected motorist will not prefer Shell. So let's first go to Shell. So this is Shell, and these are the chances of finding Shell. So this is what you do. You just apply what we've done there. So PA is the probability of finding Shell, then which will be 22 divided by 50. When you divide that and you use your calculator, you get something like 44. Therefore, the complementary, which I'm going to represent here as PA like this, will be 1 minus P minus PA. Okay, so 1 minus PA. And for our scenario here, which is equal now to 1 minus 0.44, which is 0.56 based on our complementary rule. Therefore, we have 56% chance of finding a randomly selected motorist that does not prefer the Shell brand. Moving on to our third question now, we are asked, what is the probability of finding a motorist who prefers either BP, Caltex, Engine, or Shell brand? Okay, so this is what we're going to do. So let's pretend A1 is equal to the probability of the motorist liking BP. A2 will be Caltex. A3 will be Engine. And A4 will be Shell. Okay, so what we're going to do then, we're going to work out the probability of A1 plus the probability of A2 plus the probability of A3 plus the probability of A4. Okay, so all that will give us then, from what we've done before, this will be equal to 13 divided by 50 plus 9 divided by 50 plus 6 divided by 50 plus 22 divided by 50. So let me just separate here. Okay, it's just continuing from here. So take up your calculator, and you see after you do all that, you will get an answer of 1. And you see now that it makes sense because we only have 4 options. When we combine all those 4 options, it gives us the highest level of probability. So we are more certain, we are 100% certain that we will find a motorist that will like one of the 4 brands, which is more likely to be true because these are the options that have been presented to us. So now at this point you can pause and reflect, go back to the video, and then our next step will be going through basic probability concept.